Okay, so 3.0. So, and again, notice that 3.0 is not in your textbook. This is just like a review of grade 9 or 8 or even like some elementary stuff, just so people kind of, have a background knowledge and some foundation going into chapter 3. And just notice that this chapter is not going to be on the unit test as well. So this is just some background information. It's going to be pretty quick, not too much to write. Pretty much it's already filled out for you. So we'll just go over it together. So let's do that. So some terminology, real numbers, all points on the number line, all rational and irrational numbers. So these are basically all numbers on the number line. Yeah, everything. So, and just notice that real numbers, they kind of encompass, they include all these other numbers as well. So whole numbers are also real numbers. Natural numbers are also real numbers. And we'll look at that in the visual aid, the Venn diagram at the bottom in a second. Okay, so I'm sure you guys can read this, but we'll just read it together. Um, why not? So whole numbers, starting from 0 and up. So these are positive numbers. So natural counting numbers, 0, 1, 2, 3, 4, all the way to infinity. Um, yeah, just notice that it doesn't include negative numbers or decimals. Okay, natural numbers. This is just same thing as real whole numbers, but we're starting from 1, so not including 0. Okay, that's the only difference. Integers can be positive or negative whole numbers. So you can see that -3, -2, -1, 0, 1, 2, 3, 4, 5, etc. Get rational numbers, numbers that can be expressed as a fraction or a quotient. Okay. Note rational contains the word ratio, repeating or terminating in decimal. So as long as you can create a number that can go as a decimal or as a fraction, non-repeating decimal, meaning that it ends. So if you can make it as a fraction, it's going to be a rational number. So you'll see numbers that you can't put as a fraction because the decimals like they don't repeat when you put in decimal form. So they're going forever, and they keep changing. So what are those type of numbers? Those numbers are irrational numbers. So this symbol over here is you got pi, right? And then you got the e there, which is Euler's number, I believe it is. It's called, and it's another number like pi, which doesn't repeat. I think it's 2.7135, etc., etc. Keeps going forever. But yeah, these numbers you can't put as fractions or irrational numbers. Then you got your prime numbers, natural numbers greater than 1 that are only divisible by 1 and themselves. So yeah, and you can't fit anything into these numbers, 3, 5, 7, 11, 13. When you divide them, they can only be divided evenly by, yeah, itself and 1, nothing else. Even numbers going up by 2s, 2, 4, 6, 8, 10, and going the other way as well. So even these are, though that they're negative, they're still even numbers. And any number or integer here that is not even obviously has to be odd by default. So you can't divide these by 2. Okay, this is a Venn diagram I was talking about. So what this kind of represents is you can see that real is in the biggest box, right? So real numbers encompass all of this stuff here. So in real numbers, all these irrational, rational, integers, whole, natural, they're all real numbers. Okay. So, and then you can kind of see irrational numbers are kind of, I guess you could think of them as like strange numbers that are kind of on their own. They're not really part of this mini Venn diagram inside the Venn diagram, I guess. So this is going to be all the numbers that you can't put as fractions, right? And then you got your rational numbers, right? And they include integers, and integers include whole numbers and natural numbers, and whole numbers include natural numbers, etc. Right? So a natural number is also a rational number, but uh, a rational number may not be a natural number. So like here, the negative fraction is not a natural number, but all these are rational numbers. Hopefully that makes sense. Okay, so let's go through some questions, and maybe this will kind of make a little more sense. So consider the list of numbers. So we got a list of a bunch of different numbers. Here's some whole numbers, integers. There's some irrational numbers in there too. And we just gotta list them out. So let's look at this list. What's a natural number? So remember, natural numbers is going to be the whole number, positive numbers um, that are that don't include 0. So we have it over here. So 1, 2, 3, and above. And from this list, you can see the only natural number I see is 40, right? So 40. Let's go to whole numbers. So what whole number do we see? Now this is gonna be like natural numbers, but including 0 as well. So 0 and 40. Integers, what integers do we see? Whole numbers that could be positive or negative, right? So we see negative 70, and you also have the 40. Integers, I don't believe 0 is included as an integer, so let me just check that out right now. Okay, never mind. 0 is included as an integer. Okay, so it's neither positive, it's a neutral number. It's not positive or negative, but still considered an integer. And then we got rational numbers. Okay, so we're gonna look through this list of rational numbers here that I see. Negative 7. This is gonna be a big list. 3.5, 0, 1 over 3. The fractions are natural rational numbers. Numbers that you include as a decimal are natural numbers. And then we got our 40 as well. So all rational numbers. Okay. Irrational numbers, the numbers that we can't put as fractions. We got pi there. You also got the square root of 3. You can't put as a fraction as well. Okay. And finally, real numbers. Oh, this is going to be the biggest number. So real numbers is going to be basically everything. Yeah, all the numbers. So without writing them all, let's say all numbers on list. Okay. Good. This last section is just going to be helpful for you when you're doing your homework. Prime numbers, we talked about just numbers that you can only divide by itself and 1. So you can't fit any other numbers inside of it. And then we talk, when you see the word composite number, and all that composite number means is numbers that are not prime numbers, basically. So numbers that you can divide by something else other than 1 in itself, and just a list. So 4, 6, 8, you can divide all these numbers by 2, or these ones at least, and 9 by 3, etc. Okay. It says note the whole numbers 0 and 1 are neither prime nor composite, so you don't really count 0 and 1. Okay, when you're trying to make a list. Okay. Divisibility properties. Okay, so this one is if you want to quickly see if you can divide a number by 2, 3, 4, 5, 6, 9, and 10, and say you don't have a calculator with you. These are some tricks. So I'm sure some of these you already know by just by doing a lot of questions. So like this one too. So if a number is even, you can divide it by 2. The ending is 0, 2, 4, 6, or 8. If something is divisible by 3, the sum of its digits are divisible by 3. The whole number is divisible by 4 if the last 2 digits are divisible by 4. You can go through this list. There's like just little tricks you can memorize, and that way, yeah, if you don't have a calculator, you can figure that out. So this practice section, without me going over it, because what you're gonna do is you're just gonna use these little tricks. So some of these, like, yeah, if some numbers ends in 0, 5 is divisible by 5, which is pretty straightforward. But say if you want to figure out something's divisible by 9, so if the sum of the digits are divisible by 9, so for example, let's do this one, 63. Okay, so 63, 6 plus 3 is 9, so 6 plus 3 is 9, so 9 is divisible by 9, so you already know that 63 is going to go to this list, right? And then I just go down here, an example, so 126, 1 plus 2 is 3, plus 6 is 9, so I know 126 is going to be a part of the list. And then you can keep going through them, just doing the same thing. So what else is there? 396. And then what else? No, 2, 8, 9. This is equals 9 as well, so 9 is divisible by 9, so no, 2000 is divisible by 9. Okay, so instead of boring, just going over this one step by step, I would say I'll post the answers, but you can just go through this yourself. So even numbers should be pretty straightforward. Go through the rule of threes. You can figure out which numbers are divisible by 3 really quickly without a calculator. It'll just help you. So this section, on the test, you'll always be able to use a calculator pretty much, because I can't really stop you or check you. So for Math 10, you're always allowed to use a calculator. But this will be good for you in the future, just to be a little bit quicker if you want to not always have to reach for a calculator. Okay, so try that out. And that'll be it for today. So just remember that tomorrow you'll have a unit test on chapter 2. and I'll provide all the homework and stuff as usual. We're just going to focus on chapter 2 today, and I'm not going to give you any work on chapter 3, so don't worry about chapter 3 for now. Okay, all right. See everyone in the meeting tomorrow.